In this session, we will introduce different types of VQ. Because there are different kinds of structures in different kinds of data, there are a number of different ways to design vector quantizer. VQ can achieve significant coding gains over scalar quantization, but at a price. There are some problems in VQ implementation. The codebook search process is complicated and causes a large computational cost. The codebook is too large and affects storage consumption. The codebook training process is complicated and affects the training complexity. Other problems like selection of code vector and distortion criteria. Faster codebook search algorithms are also important in VQ designing. For conventional VQ, codebook memory and encoding complexity are exponentially related to the vector dimension and bitrate. A variety of structured VQs, like multi-stage VQ, split VQ, can be considered to treat a little bit of this performance advantage for a very large reduction in memory and complexity. There are many variants of VQ methods. The full search VQ is an original VQ method based on LBJ algorithm. For each input vector, compare it with the distortion of the code word in each codebook, and use the code word label with the smallest distortion as the output. Full search VQ needs much computation. We will mainly introduce several structured VQ methods, such as tree structured VQ, split VQ, and multi-stage VQ. Other methods like gain shape VQ and mean removed VQ belong to product VQ. When doing decoder by VQ, for every vector, the search is needed for getting its code or label. In general, we need a search for every center. Such kind of full research VQ takes much time. If we can create a tree of codebook and keep all levels of the code words, then the search will be easy. The cost is about double storages. The figure shows the method of binary tree VQ. As shown in the figure, a binary tree with codebook size m equals 8, its codebook contains a total of 14 code words. The input signal vector is x. First, compare it with y0 and y1 to calculate the distortion dxy0 and dxy1. If the latter is smaller, take the following branch and send one output at the same time. Similarly, if y101 is finally reached, the output index sent to the channel is 101. This process belongs to the process of binary tree vector quantization. In order to reduce the codebook storage and searching computation, the split VQ is used. First of all, a k-dimension vector is divided to p subvectors, p bigger than 1, and then to character VQ for each subvector. In an actual VQ system, for example, 20 bits are used to quantize 10-dimension LSF. If the full search scheme is used, the codebook capacity will reach 2 to the 20th power times 10. Whether it is from the storage capacity of the codebook or the amount of search calculations, it is difficult to realize in real time under the existing hardware conditions. If the split vector quantization algorithm is used, the 10-dimensional LS vector is split into two 5-dimensional vectors, and VQ is performed with 10 bits respectively, so that the codebook capacity is reduced to 2 times 2 to the 10th power times 5. The multi-stage VQ will quantize the input vector with several stages. For each stage, the difference between the input vector and the output vector leads to the error vector, which will be quantized with another vector quantizer in the next stage. Each stage has its own codebook trained ahead. The multi-stage VQ can greatly reduce the computational complexity and storage capacity of the vector quantizer. For example, 20 bits are used to quantize the 10-dimension LSF parameters. A 3-stage vector quantizer is designed with 7 bits, 7 bits, and 6 bits for each stage. The codebook capacity is reduced largely. Compared with the split vector quantization, the storage capacity is reduced by 60%, and the corresponding search calculation is also greatly reduced. The synthesized speech quality of multi-stage VQ is basically equivalent to that of the split VQ at the same bit rate. The multi-stage vector quantization system has made considerable improvements in terms of reducing the amount of search calculations and reducing the amount of codebook storage. VQ methods can also be classified into memoryless VQ and memory VQ. As to memoryless VQ, each vector of the quantizer does not depend on other vectors before this quantization. That is, each input vector is quantized independently. The structure VQ and product VQ belong to memoryless VQ. Memory VQ means when quantizing each input vector, it is not only related to the vector itself, but also related to the previous vector. When quantizing, it uses the information of past input vectors through memory and the correlation between vectors, thereby improving the performance of vector quantization. Memory VQ has two kinds of methods. One method is feedback VQ, which contains predictive VQ and finite state VQ, FSVQ. Compared with the general vector quantizer, predictive VQ makes a full use of the correlation characteristics between the adjacent vectors, and uses the prediction method to remove redundancy code words, so as to ensure that the quality of the decoded signal is equivalent to that of the general vector quantization. FSVQ contains n finite states. Each state has a VQ encoder and a VQ decoder and a codebook. When encoding, in addition to outputting the index of the code word with the least distortion in the codebook, the next state is also given. In other words, the state of each encoding and quantization is determined according to the previous state and the previous encoding result. Another method is adaptive VQ, which uses multiple codebooks, and different codebooks are selected according to the different characteristics of the input vector during quantization. That's all for this chapter. See you next chapter.